Have you ever looked up at the night sky and felt a sense of wonder? All those tiny pinpricks of light are actually gigantic burning balls of gas, just like our sun. But have you ever stopped to think about how big they really are? Today, we're going on an epic journey across the cosmos to compare the sizes of stars, from the smallest to the absolute titans of the universe. It's a journey that will truly boggle your mind. Let's start with something familiar. Our home, planet Earth. About 1.3 million Earths could fit inside the sun. That's a staggering number, right? The sun feels immense to us, a colossal powerhouse that governs our entire solar system. Its diameter is about 1.4 million kilometers. It's a pretty average star, classified as a yellow dwarf. But in the grand cosmic scheme of things, our sun is, well, let's just say it's not winning any size contests. To begin our comparison, we need to find stars even smaller than our sun. Yes, they exist. Let's talk about red dwarfs. These are the most common type of star in the Milky Way. A great example is Proxima Centauri, the closest star to our solar system. It's only about 1/7 the diameter of our sun. If our sun were a basketball, Proxima Centauri would be like a small orange. These stars are cooler, dimmer, and live for trillions of years, far longer than stars like our sun, but we can go even smaller. Neutron stars are the collapsed cores of massive stars that have gone supernova. They are incredibly dense. Imagine cramming 1.5 times the mass of our sun into a sphere just 20 kilometers in diameter. That's about the size of a city. If our sun were a basketball, a neutron star would be smaller than a grain of sand, yet much, much heavier. They're not technically stars in the traditional sense because they don't generate heat through fusion. But their place in the stellar life cycle is crucial, and their size is mind-bendingly small. Okay, let's scale back up. We've seen the small fry. Now, let's get back to our sun, our basketball-sized reference point. What's the next step up? Let's look at a star like Sirius, the brightest star in our night sky. Sirius is a main sequence star, about 1.7 times the diameter of our sun. So, next to our basketball sun, Sirius would be a larger beach ball. It's noticeably bigger and much more luminous. Now we're leaving the realm of the familiar and entering the land of giants. Let's talk about blue giants like Rigel, the bright blue-white star in the constellation Orion. Rigel is a true heavyweight. Its diameter is about 78 times that of our sun. If our sun is a basketball, Rigel would be a giant sphere, about 21 meters tall, roughly the height of a 7-story building. We're already dealing with something that would dwarf a house, and Rigel isn't even close to the top. The next category is red giants. When a star like our sun runs out of hydrogen fuel in its core, it begins to swell up, becoming a red giant. A famous example is Aldebaran, the fiery eye of Taurus the bull. It's about 44 times the diameter of our sun. While smaller than Rigel, it represents a future stage for many stars. Our own sun will one day become a red giant, expanding so much it will likely swallow Mercury, Venus, and possibly even Earth. It's a dramatic end-of-life transformation. But Aldebaran is just a small-time giant. Let's meet the real contenders, the supergiants. We'll start with a famous one, Betelgeuse, the reddish star in Orion's shoulder. Betelgeuse is a red supergiant, and it's a bit of a variable, but its diameter is estimated to be around 900 times that of our sun. Let that sink in. If we placed Betelgeuse where our sun is, its surface would extend out past the orbit of Mars and maybe even reach Jupiter. Our basketball-sized sun is now compared to a colossal hot air balloon over a kilometer wide. All the inner planets would be inside this star. You think that's big? We're just getting started. The universe has a way of always one-upping itself. Let's travel to the constellation Canis Major and meet the aptly named VY Canis Majoris. This is a red hypergiant, a class of stars that are among the most massive and luminous known. For a long time, it was considered one of the largest stars. Estimates place its diameter at around 1,420 times that of our sun. If our sun is a basketball, VY Canis Majoris is a sphere nearly 2 kilometers across. If it were at the center of our solar system, its surface would stretch out past the orbit of Jupiter. But even this cosmic monster has been dethroned. As our telescopes and measurement techniques get better, we keep finding bigger and bigger stars. Let's try to visualize this. If you replaced our sun with Stephenson to 218, its surface would engulf the orbit of Saturn. Saturn, a planet that takes light almost an hour and a half to reach from the Sun, would be inside this star. Let's put this another way. A commercial airplane flying at its cruising speed would take over 1,000 years to circle Stephenson to 218 just once. It would take light, the fastest thing in the universe, about 9 hours to travel around its circumference. Imagine our entire solar system out to Saturn, not as a vast expanse of empty space with a few tiny planets, but as the fiery interior of a single star. That is the scale we are talking about. Our home Earth would be a vaporized speck deep within its plasma. Our Sun, the star that seems so immense to us, is an insignificant dot in comparison. It's humbling, isn't it? This journey from a city-sized neutron star to a star that could swallow entire planetary systems shows us just how diverse and extreme the universe can be. The stars we see at night are not all the same. They are a celestial zoo of dwarfs, giants, and supergiants, each with its own story, its own life cycle, and its own incredible scale. These colossal stars, like Stephenson 2218, live fast and die young. They burn through their fuel at a ferocious rate and will end their lives in a spectacular supernova explosion, scattering heavy elements across the galaxy. These elements will then form new stars, new planets, and perhaps one day, new life. So, in a way, we are all made of stardust, forged in the hearts of giants that lived and died long ago. The next time you look up at the night sky, remember what you've seen today. Remember the tiny red dwarfs and the city-sized neutron stars, and remember the titans, the hypergiants, so large they defy imagination. Our universe is bigger, grander, and more awe-inspiring than we can ever fully comprehend. If you enjoyed having your mind blown, do not forget to hit that like button and subscribe for more journeys into the wonders of our universe. What topic should we explore next? Let me know in the comments below. Until next time, keep looking up.